Jan,
Present, ma'am.
Dipanjan,
Yes, ma'am.
I have seen most of the things you have not submitted. You are not attending classes. What is the reason? May I know?
Ma'am, submitting.
Huh? What happened? What happened? Tell.
No, I am attending classes.
What you are not attending classes. You have not submitted any assignments. You are not up to date. Unnecessarily, you lose your grade, right? Always you are defaulter. Abhijit,
Present, ma'am.
Adarsha,
Present, ma'am.
Anand,
Present, ma'am.
Akash,
Present, ma'am.
Ananya,
Present, ma'am.
Anika,
Present, ma'am.
Ananya Singh,
Present, ma'am.
Ankit,
Present, ma'am.
Aryak,
Present, ma'am.
Arnav,
Present, ma'am.
Prakhar,
Present, ma'am.
Aryaman,
Present, ma'am.
Bhavya,
Present, ma'am.
Vaishnavi, Ashish,
Present, ma'am.
Aryan,
Present, ma'am.
Satya Sarangi,
Yes, ma'am.
Satyabrat, Saurav, Satyabrat
Ma'am,
is
present, ma'am. Present.
Saurav,
I'm sorry, present. है.
Present, ma'am.
Sayak,
Present, ma'am.
Shivam,
Present, ma'am.
Simran,
Present, ma'am.
Subhranshu,
Present, ma'am.
Supriya,
Present, ma'am.
Swapnadeep,
Present, ma'am.
Vinita,
Present, ma'am.
Ankit Sinha,
Present, ma'am.
Ankit Senapati,
Present, ma'am.
Anurag,
Present, ma'am.
Anushka. Anushka is absent. So, last class, which experiment we have done?
Hello, ma'am. I am roll number 829. I am present, ma'am. I couldn't mark it on time.
Ma'am, 811.
800.
11.
Priyam Ghoshal, are you present? Priyam Ghoshal, Pratyush,
Present, ma'am.
Pallavi,
Present, sir.
Neil, Kunal,
Present, ma'am.
Kaustav,
Present, ma'am.
Kartika, Ritik.
Seven 85.
780.
87. Ma'am, 785.
Yes, ma'am. I'm present. 780.
Ayushi, Vibhu Kalyani.
Yes, ma'am. Present.
Okay. Those who have remained absent, I have not marked. You will tell me later on. So now last thing we have RLC we have completed, na?
Yes, ma'am.
Today we will go to
Ma'am, 3 ohm load.
3 ohm नहीं ये 3 phase है.
Okay, 3 phase.
So what do you mean by 3 phase? Before going to 3 phase, I will see this is a 3 phase experiment. This experiment is related to 3 phase. So because I have not started 3 phase in your theory class, whatever is required for your lab, I will discuss. Okay. And rest of the things I will discuss in the theory class. So now coming to 3 phase. 3 phase, how will you write? 3 pi. Okay, this implies this we are telling it as 3 phase. Okay, and 1 5 means here this is known as what? Single phase. This means got it?
Yes, ma'am.
So that means here we are getting 3 flux Here we are getting one flux. Okay. Here we are getting one flux. In case of single phase, we are having only one flux, and this is changing. This is your maximum value of the flux. Okay. This one is the maximum value of the flux. This one is phi. This one is your omega t. So I will write down the flux equation as phi m sine omega t. Like your current is sinusoidal, I is equal to Im sine omega t, and voltage is also sinusoidal, that is Vm sine omega t. These are all instantaneous value. Similarly, we are writing the flux as phi equal to phi m sine omega t. Because when you are passing a current, listen all of you very carefully, because I will be asking question before going to the experiment part. So when you are passing a single phase current, or when there is a single phase current, this will give rise to a flux. Okay, because this one is your sinusoidal, this one is your sinusoidal current or voltage you are giving. Voltage is also sinusoidal, this is current. Okay, this is also sinusoidal, and flux is also sinusoidal. Got it, all of you? Okay, but in case of your three phase, how many flux are there? Three phase means you will be having three flux. Okay, three flux will be there. See, again and again I am telling you, you may have, I will skip something. I am not going to tell you details. Details I will tell you in the theory class, everything. So here this is one flux. Okay, where this one is, what is the equation of this one? So there are three phase. So we are having three flux, phi 1, phi 2 and phi 3. Or most of the cases we write it as phi A. Three phase are A, B or C. Or in some cases we tell it as red, phi R, phi Y or phi blue. RYB stands for what? Red, blue, yellow. Have you seen a three-phase connection? Have you seen most of the houses of we are also taking three-phase connection? Have you seen? Huh? Have you seen or not? Tell me.
Yes, ma'am.
Have you seen or not? Raised raised 90 students. Why you are?
Ma'am, hard.
Ma'am, please again repeat.
I am telling you. Have you seen three-phase connection anywhere?
Yes, ma'am.
No, ma'am.
You have not seen.
Ma'am, hard only.
Hard only. Okay. Nowhere you have seen three-phase connection. You have never gone through ट्रेन में गए हो?
Yes, ma'am.
Yes, ma'am.
तो ट्रांसमिशन लाइंस देखे हो?
Yes,
Yes, ma'am.
Yes, ma'am.
वो जो कनेक्शन जो वायर से वो क्या कैसे कनेक्शन हुआ है? वो थ्री फेज ही वायर है या सिंगल फेज? आवर पावर इज हाँ वो तो थ्री फेज. तुम देखे हो? पता नहीं है. हाँ क्या है कनेक्शन है, जा रहे हैं तो क्या वाइट्स तो है, आ रहा है,
हमें इलेक्ट्रिसिटी
है ना? हाँ वही है. मुझे सब बोलो, मुझे पता है सब. हाँ ठीक है. So we are having three-phase wire, where the three-phase wires, they are represented as R, red, Y for yellow, B for blue. Now, what is the phase difference? Among these two, we are having 120-degree phase difference. Between Y and B, we are having 120-degree phase difference. Between B and R also, we are having 120-degree phase difference. Okay. So here I want to tell you, तुमको जो कम मैं बोल रही हूँ ना, मुझे भी प्रॉब्लम हो रहा है. So here I want to tell you that we are having three phase voltages. We are having VR, VY, VY and VB. All are, this is VR. This is out of 120-degree out of phase from this is VY and this is your VB. Between these two, we are having a phase difference of, already we know the phase difference, theta. Okay, here between these two, we are having a phase difference of 120 degree. Between these two, we are having a phase difference of 120 degree. Am I clear up to this? Or anybody having any doubt? Whatever I am telling you from there, if you are having any doubt, tell me. Any doubt?
No.
Any doubt? Tell me.
No,
Okay.
ma'am.
So
No, ma'am.
we are. So these three voltages we are, understand all of you very carefully because this is difficult. Vy and Vb, all magnitude are same. Magnitude are same. Okay, or magnitude are equal. Okay, this Vr is equal to Vy is equal to Vb, or magnitude are equal if the system is balanced. In your course, only balanced system is there. Unbalanced system is not there. Okay, so this is equal, the magnitude is equal. Magnitude is equal in which case? In which case the magnitude is equal? Tell me.
Ma'am, when the
Balanced system.
P is balanced.
Yes, when the system is balanced. I will tell you obviously what is a balanced system. Okay. So remember that in three phase we are having three voltages and they all are equal in magnitude if the system is balanced. Okay. So now come here, I was discussing about the three phase, why I am writing three flux. So we are generally, because of these three phase voltages, we are having three phase flux. Okay. And here you see, what is the phase difference between all these voltages? 120 degree, right?
Yes, ma'am.
So here,
Yes, ma'am.
if we will divide this 30, 60, 90, 120, 150, this is 180 degree. Understand very properly. This is 180 degree. This one is my 360 degree, right? Okay. So phase difference is 120 degree, means the second phase will start after how much degree? 120 degree. Understood all of you? Got it or not? Tell me.
Yes, ma'am.
Simple way I am explaining. Okay. Now next one is, this one is 30, 60, 90. No, this is 180. This is 200. 10, this is 240, this one is how much? 270, this is 300, 330, 360. Now here you see one thing, just briefly I am telling you, details I will tell you in the theory class. Okay. Then next zero reference will start how much degree? 30, 60, 90, 100. How? Yes, it will start from here. Understood all of you? Okay, so we are having a phase difference of here 120 degree and here also 120 degree. Understood? This one is your
Yes, ma'am.
VA, this one is your VB, this one is your VC. Okay, clear to all of you? Or V, understood all of you? I hope all of
Yes,
you are
ma'am.
getting VA, or we can write that take it as a VR, which I have taken. VB, we are taking it as VY. VC, we are taking it as VB. Understood? Okay. Clear to all of you, or tell me. Anybody having doubt, don't feel shy to ask. VY, this one I am taking it as VB, and this one is your VB or VC. Clear to all of you or not? Tell me.
Yes,
So
ma'am.
that is the reason. Okay. So details again I will repeat. Don't worry. For this doing the experiment, whatever is required, I am telling you. So 0 of the VB will start after 120 degree. Then VC will start again after 120 degree. So this process will go on. So we are having three flux. Okay. So this is a three-phase system. We are having three voltages equal in magnitude and three flux also. That is the reason why we are writing three phase. We are writing 3 phi, like this. Okay. Now, so for here, how many conductors we require for transmitting three-phase voltage or providing three-phase voltage? How many conductors we require? How many conductors? You see, how many conductors we require? Tell. How many conductors we require? How many conductors we require for three-phase transmitting three-phase voltage or providing three-phase voltage? How many conductors we require?
2, ma'am.
Why 2?
Ma'am, 3.
2 कैसे आ गया? दिमाग में 2 क्यों आया? P तो voltages है, 3 conductors तुमको आया. One single phase, how many conductors required?
One conductor.
3 phase we require 3 conductors.
3 conductors.
Okay. जल्दी आंसर दे रहे हो, इतना स्मार्ट स्टूडेंट हो मेरे. So we are having 3 conductors. So this one is, let this is A1, this is B. Listen to me here carefully. B B1, this is C C1. 3 conductors are there. यहाँ पर तो दिखाई 3 voltages. So 3 conductors are there. So now how will you connect these 3 conductors? So we are having 2 types of connection actually. One is star connection, star, or we call it as Y connection. Star or Y connection. Second one is delta connection. Second one is delta or this symbol. Y, this symbol, this is your delta connection. Okay. Now, how will you connect these 3 windings such that it will be, this one I will not teach you now because this one you will not perform any experiment. You will do only star connection. Okay. Anjana madam, delta res mane korchandi ki? Anjana madam?
Nine, madam.
Okay. So, how will you connect these 3 windings in star? So, we are having 3 conductors, A1, another one is what? A1, another one is B1, another one is your C1. Okay. If I am connecting any 3 similar ends, I am connecting here what? A1, B1, C1, 3 similar ends I am connecting, then connecting to a single point, then this point is called as neutral point. Okay. And this is one line, this point is your A, this one is your B, this one is your C. Got it? How you will do the neutral connection? Sorry, 3-phase star connection. Got it, all of you? If you want to repeat, tell me. Madam, repeat. Understood?
Yes,
all of you? How the connection is being done? Okay. So here if I am taking the voltage between, in order to take the voltage, I need 2 conductors. If I am taking the voltage between one, this is one line, this is another line, this one is another line, this line we call it as neutral, right? If I am taking the voltage between any line to neutral, between A and N, this point is neutral. Between A and N, between B and N, between C and N, then these are called as the phase voltages. Phase voltage. Between any line to neutral, we call it as phase voltage. Am I clear to all of you? What is phase voltage?
Yes, ma'am.
Okay. To your home, which voltage you are getting? You are getting phase voltage? Yes or no?
Yes, ma'am.
Respond quickly.
Yes,
so you are getting phase voltages to your home. So your house is connected either between A and N, or between B and N, or between C and N. Here one thing I will tell you. in some cases you have observed that you are suppose there is some failure, some disturbance has occurred. In some cases you are getting the supply, you will see that your neighbor is not getting the supply, or somewhere your neighbor is getting the supply, you are not
Yes, ma'am.
getting the supply. Have you ever observed it or not?
Yes, ma'am.
Yes, ma'am.
That means if your house is connected between A and N, okay, between these phase, suppose your house is connected, their house, your neighbor house is not connected in between A and N. Rather, it will be connected between B and N or C and N. That means their phase and your phase is different. Okay, you in your phase, if you are getting some disturbance, you are not getting the supply, but they will be getting the supply because they are not connected to your phase. Their phase is different than your phase. Understood, all of you?
Yes, ma'am.
Yes,
Okay,
ma'am.
so these are the any line to neutral. Line to neutral is called as the phase voltage, B and N, C and N. And all these phase voltages are equal in magnitude and are 100 equal in magnitude. Why it is an equal in magnitude? Because I have assumed that my system is a balanced system. Okay, equal in magnitude and are having how much degree phase difference? 120 degree phase difference among each other. Okay, phase difference. Clear to all of you?
Yes, ma'am.
Got it? Okay. So this I can write as VAN is equal to VBN is equal to VCN. All the magnitudes are equal for a balanced system. Okay. But practically our system is not balanced. Okay. Balanced system and unbalanced system, I will tell you. Just wait. Now coming to this one, this circuit diagram, if I am taking the voltage between any two line, between A and B, okay, between A and B, if I am getting the voltage, this is one line voltage. Between B and C, if I am taking, this is a line voltage. Between C and A, if you are taking, then this is a line voltage. That means between any two lines, if I am taking the voltage AB, BC, then CA, these three voltages are which voltage? Line voltage. Got it, all of you? Understood what is line voltage and what is phase
Yes,
voltage?
ma'am.
Tell me what is the definition of phase voltage? Phase voltage is any voltage between what? Phase
Line
voltage
and
is
neutral
what?
point.
Line and neutral. Okay, that is your phase voltage. And what is your line voltage? Line voltage is voltage between what?
Any two lines.
Between any two lines. This is your line voltage. Now come to the current. Now in star connection, the relation between this one I will derive in the theory class. In star connection, the relation between this phase voltage and line voltage, phase voltage and line voltage, phase voltage we denote it as capital V with subscript PH, line voltage we denote it as capital V with subscript L. Okay, for star connection, delta connection, it will be different. For star connection, V phase is equal to VL divided by √3. Okay, this is the relation between phase voltage and line voltage for a star connection. This one I will derive it in the theory class, I will derive. Okay. Now in case of, now come to the current. Okay, the current which is flowing in the line, okay, this is your which current? Line current. Okay, this is your IA, this one is your which current? IB, this one is your IC, the current which is flowing in the line. Okay, now the current which is flowing in the between the line and neutral, okay, line and neutral, this current is your which current? This current is your phase current. Okay. So here you see one thing, the current which is flowing in the line is flowing between the line and neutral, this current. This current and this current same. Am I clear or not? Tell me. Is it clear to all of you or not?
Yes, ma'am.
Yes, ma'am.
Here you see, you are having, this one is the 3 windings, okay. So this current which is flowing in the line here, this is also flowing in the neutral, in the between line and neutral, okay. This is my neutral. So here I can write that the line current is equal to which current? Is equal to your phase current. Clear to all of you? Similarly, this current is your IB, this is your IA, IB, this current is flowing. For IC, here this current is flowing. Okay, so this current is your which current? IC. And this is your neutral current, IN. So in this case, you are getting that phase current, it is denoted by capital I with subscript PH. Line current, it is denoted by capital I with subscript L. So for this case, you see, what is the relation between line current and phase current? Tell me. Look at the figure and tell me. What is the relation between line current and phase current? What is the relation between line current and phase current? तुम लोग जाओ, बंद करके जाओ, अटेंडेंस दे दी, सब भाग जाओ, बंद कर दो, क्लास बंद करो, जाओ, चले जाओ सब, अटेंडेंस आई हैव गिवन यू, जाओ. क्या सुन रहे हो, ये क्या कर रहे हो, मुझे पता नहीं चल
सुन रहे हैं,
क्या सुन रहे हो. इतना कुछ बोलने के बाद लाइन करंट और फेस करंट का क्या रिलेशन है? आई हैव ऑलरेडी शोन यू इन द सर्किट. इक्वल बोलने के लिए कितना टाइम तुम लोग को लगता है?
मैम सोच रहा था गलत ही सही है मैम.
क्यों?
वही मैम,
कंफर्म इक्वल फेस करंट होगा.
कंफर्म, ये तो लिखी हूँ, लाइन करंट तो यहाँ पर लिखी हूँ, फेस करंट लिखी हूँ, और क्या? So line current is equal to how much? Phase current. Okay. So IL is equal to I phase for star connection. Again I'm telling you, I am only discussing about the star connection. Now neutral में कितना current जाएगा? What is the current in the neutral? Tell me. Neutral, here which current is coming? IA. Here which current is going? IB. Here which current is coming? IC. So what is the current in the neutral? Neutral will be equal to how much? Tell me. Neutral current equal to IA plus IB plus IC. Okay.
Yes, ma'am.
So now here I will tell you one thing. Here I want to tell you one thing. Like your voltages in a balanced system, all the voltages are equal in magnitude. Similarly, all the currents are also equal in magnitude. IA, IB, IC, they all are equal in magnitude. Okay. And what is the phase difference? And are 120 degree apart from each other. Like your voltage, the currents are also equal in magnitude and are 120 degree apart from each other. Clear to all of you? This is for which case? For, again I am telling you, for balanced system. Okay, for balanced system. Am I clear to all of you?
Yes, ma'am.
So now if I will tell you all are having equal magnitude and are having, listen to my question, you will answer. All are having equal magnitude and are 120 degree apart from each other. What will be the resultant? I need what is the current in the neutral. Neutral में current कितना जा रहा है in a balanced system. तुम लोगों का कोर्स में balance system है. और जो this one whatever I am teaching you, when I will start 3 phase, I will ask question from this one. बोलो. Current कितना जा रहा है? Current is my IA plus IB plus IC. Now my question is, all the magnitudes are equal and are 120 degree apart from each other. What will be the resultant? That means what is the neutral current? What is the current in the neutral when the system is balanced system?
Ma'am, I think 0, ma'am.
Who answered this one?
Shivam.
Shivam?
Yes, ma'am.
Very good. So it will be 0. How is it? Look at here. This is my IA. IB, I have told you, this is 120 degree apart from each other. Then IC, it is also 120 degree. Now first what I will do, I will add IA with IB. If I am adding IA with IB, then how much I am getting? This is IA plus IB. Now if I will add with what?
IC.
IC, then what will be the resultant? This one will get cancelled. What will be a resultant? Neutral current is 0. Got it?
Yes, ma'am.
Okay. So here in a balanced system, there is no current flowing in the neutral. In a 3-phase balanced system, no current in the neutral. These short questions you will get, remember. Okay. So this is your 3-phase, all about the 3-phase star connection. 2 formulas you have to remember. One is related to the phase voltage and line voltage. Line voltage divided by √3 is your phase voltage, and phase current is equal to line current. Okay. तुम लोग जो देखे हो जो single line diagram which I have explained in the module 1. There you have seen, and somebody, I think somebody have asked, secondary distribution system. In the last you have seen secondary distribution system where the small consumers are connected. You have seen this one. Here secondary distribution system, small consumers are connected. There it is written 400 volt. Have you observed?
Yes, ma'am. तो स्टार्टिंग में अपने एक पिक्चर दिखाया था।
हाँ, 400 वोल्ट जो है वो कितना है? दिस इज आवर लाइन वोल्टेज एक्चुअली. ओके, डिवाइडेड बाय √3. डिवाइड स्मॉल कंज्यूमर्स जो है हम लोग की स्मॉल कंज्यूमर्स है. ओके, so 400 divided by √3 is how much? Line voltage divided by √3, that is your nothing but your phase voltage. Okay, so 400 divided by √3, this is coming near to 230 volt, which we are getting.
Yes, ma'am, 230 volt.
ये 230 volt क्या है? AC है DC है? जल्दी बोलो आंसर.
AC.
AC कैसे मैग्नीट्यूड कांस्टेंट रहता है? How the magnitude is remaining constant for AC? Quick answer.
RMS value.
We take RMS value.
No, one girl student tell me.
Ma'am, RMS value.
Yes, very good. Who answered this one?
Ma'am, Ayushi.
Ayushi. Very good. अरे आंसर तुम लोग को सडनली आना चाहिए. ये 230 volt, somebody will tell you how the magnitude is constant. Madam, this is the effective value. Immediately answer will come. तुमको don't think you are a computer engineer or nobody will ask you about electrical basic things. Don't think. Somebody will ask you, this is AC or DC. AC means the voltage is changing. बैटरी का वोल्टेज जो लैपटॉप में लगा रहे हो 9 वोल्ट है, दैट इज यू आर टेलिंग एज ए कांस्टेंट वोल्टेज, एंड घर में आ रहा है वो भी बोल रहे हो कि 230 वोल्ट, दैट इज आल्सो ए कांस्टेंट वोल्टेज. व्हाट इज द डिफरेंस बिटवीन बैटरी इज द डीसी वोल्टेज, जो व्हाटएवर द वोल्टेज इज कमिंग टू योर होम, दैट इज एसी वोल्टेज. So somebody will ask you definitely. So you should able to answer now, whether irrespective of whatever the branch you are having. Understood or not? These are all the basic things. So 230 volt, somebody will ask you how that is an AC voltage. Why it is not a DC? You are telling a constant values irrespective of the time. Whatever at any time period you are telling a 230 volt. That is a root mean square value. I have already told you how the root mean square value is calculated. Okay. So this one is your 230 volt is your which voltage? That is your phase voltage which are coming. Okay. So that means in India actually in the distribution side we are having star connection. Okay. Details I will tell you in the theory class. For star connection you see we require 3-phase 4-wire system. What is a 4th wire? Here you see nobody has asked me question. I was expecting question from you. I told you this is 1 wire, this is 2 wire, this is 3 wire, but this is a neutral. I was expecting somebody will ask you. Yes, this is the 4th wire. Okay, 3-phase 4-wire system is our star connection. For star connection, we require a 4th wire. That 4th wire is called as the neutral wire. Am I clear to all of you? Got it?
Yes.
Whereas
Yes, ma'am.
in case of a delta connection, we don't require a neutral wire or we don't require the 4th wire. We can transmit the voltage by using 3-phase. So delta connection, we call it as 3-phase 3-wire system. But star connection, we call it as 3-phase, how many wires? 4-wire system.
4 wire.
Okay, clear to all of you? This is what about the basic thing, and details I have not, I have skipped many things. I will discuss in the theory class.
Yes,
Okay, everything I will discuss again in the theory class. Don't worry, because for
मैम
laboratory
ये वाला जैमबोर्ड थोड़ा शेयर कर दीजिए.
Jamboard share कर दूंगी. ठीक है,
Yes,
share
ma'am.
कर. Okay, so here only 2-3 things you should remember. What is the phase voltage? Any line to neutral, it is a phase. Yes, one thing I forgot to tell you. What is a balanced system? Always I have told you what is a balanced system and what is an unbalanced system. What do you mean? Tell me. Balanced or unbalanced? You are going to bring some vegetable. You are putting some vegetable there, and the shopkeeper is putting some weight in the other side, and it is making the system balanced. Yes or no? So what exactly you mean in this case? Who can answer me? I expect the answer
Ma'am,
from you.
Ma'am, when
Ma'am,
all
loads
the
are
phases
equally distributed in 3 phases.
जोर से बोलो, सुनाई नहीं दे रहा है.
Loads are
Magnitude
equally
equally
distributed in all the
distributed.
phases.
Yes. When loads are equal, suppose from between A and N, this is A, N, B, N, this is C. Between A and N, suppose we are keeping load 5 kilowatt, B and N keeping 5 kilowatt, C and N we are using 5 kilowatt. Then we will tell that the system is my balanced system. Okay, practically is our system balanced? Practically is our system balanced? Tell me.
No.
Practically, there will be some losses.
Loss तो रहेगा, loss तो होगा.
Ma'am, theoretically
Practically-
balanced तो होगा ma'am. Practically, ma'am, there should be any losses.
हाँ, loss तो रहेगा. There will be losses. But are the loads we are using, they are balanced? Big no. Okay, practically our system is not balanced, rather our system is completely an unbalanced system. Okay, unbalanced system. तुम देखोगे तुम्हारा घर में एक 5 kilowatt if when your father has brought the connection, you must have you will see in the electricity bill some kilowatt for 5 kilowatt load or 8 kilowatt or 10 kilowatt load you must have connection. तुम लोग क्या करोगे? एक AC है और एक AC ले आओगे और एक AC ले आओगे. Yes or no? लगा दोगे. ऐसा होता है. हाँ, yes or no? Yes. So now how will be our system balanced? Our system is a unbalanced system. Understood? Clear? Balanced system, whatever you are reading, you will be reading in the theory, you will reading in the balanced system. Unbalanced system is practically whatever we are using actually, that is an unbalanced system. Okay, chalo. Now you will do the experiment. Look at here.
Ma'am, can you please share the link, ma'am? That
Which link? Laboratory ka?
experiment, yeah, ma'am.
Yes, I will say. So this is experiment number what? 7, no?
Yes, ma'am, 7.
Yes, ma'am, 7.
Okay. To measure the 3-phase here, what? Yes. Another thing, there, this one also I will teach you. Experiment will not take you take much time. Within 15-20 minutes, you will complete your experiment. Don't worry. So here, to measure the 3-phase power, what is your single phase power? Tell me. Single phase power का formula क्या है? मुझे बोलो तो. बोलो. Single phase power. Tell me. सिंगल फेज पावर का फॉर्मूला क्या है? सिंगल फेज सर्किट आई हैव टॉट यू
मैम I square R
I square R, that is equal to how much? VI cos theta.
cos theta.
Cos theta.
Okay, VI cos theta, remember this one.
Yes, ma'am.
Single phase power is your VI cos theta. Okay, and power is always consumed in the resistor. Inductor hai, capacitor hai, does not matter. Power is only consumed in the resistor.
Resistor.
Okay, so single phase power का formula है VI cos theta. Three phase power formula is your 3 into VI cos theta. 3 into VI cos theta, where this is instead of VI we will write down phase voltage, phase current, and theta is the angle between which one? Angle between, here theta was the angle between what? V and I. Similarly, here theta is the angle between what? V phase and I phase. Understood or not? Clear to all of you?
Yes.
Yes. So this is in case of a star connection. What is the relation between phase current, phase voltage and line voltage? This is 3 multiplied with VL divided by root 3. And I have told you I phase is equal to IL into cos theta. Am I clear?
Yes, ma'am. Yes, ma'am. Clear.
So this will be equal to how much? Root 3 VL IL, how much? Cos theta.
Cos theta.
This is nothing but your which power? 3 phase power. Understood?
Yes.
3 phase power is your root 3 VL IL cos theta. Now these 3 phase power can be measured. These 3 phase power can be measured by using, it can be measured by using 2 ways. Okay, by using 2 methods. Okay, measured by 2 ways. First is what? You can use a 3 phase wattmeter. Okay, जो laboratory में use करोगे 3 phase wattmeter you can use and you can measure directly the 3 phase power. Okay, whatever the wattmeter reading so. Otherwise, in the second case, instead of using a single 3 phase wattmeter, here we can use a single 3 phase wattmeter, or else in the second case we can use 2 single phase wattmeter. 2 single phase wattmeter. Understood or not? Tell me. We can use 2 single phase wattmeters. Suppose one reading will show you, understand all of you very carefully, W1, another reading will be W2. So from here W1 plus W2, whatever the 2 single phase wattmeter reading will give you, W1 plus W2 will be equal to root 3 VL IL. What is your 3 phase power? Root 3 VL IL cos theta. Understood?
Yes, ma'am.
Never tell theta is the angle between VL and IL. Never tell. Remember, even if I have written VL IL, theta is the angle between what? Phase voltage and phase current. Got it? I have written here. Theta is the angle. Everything I have written. Whatever I am telling you, I am always writing. Theta is the angle between what? P phase and I phase. Okay? Got it? So here, W1 plus W2, instead of using a single 3 phase wattmeter, we can use 2 single phase wattmeter. Whatever the reading will give you W1 plus W2, you will just add it. This will give you what? Root 3 VL IL, how much? Cos theta. That is nothing but what? 3 phase power. So the 3 phase power can be measured by using what? 2 single phase wattmeter, or in short we tell it as 2 wattmeter method. The 3 phase power can be measured by using 2 wattmeter method. This proof is there in your theory. I will discuss in the theory class. Am I clear up to this, all of you?
Yes, ma'am.
Yes, ma'am.
Okay. So now we will move to the lab. Yes. Here you see W1 plus W2. W1 is equal to this one formula. Remember, just for the time being, you remember in the theory class, I will discuss. W1 is this one, W2 is another wattmeter. Both are two single phase wattmeter. So here you see I have written the formula, W1 plus W2 is equal to root 3 VL IL cos phi. In my case I have taken theta, here it has taken phi. Okay, so here you see, look at here. Here we have used given three phase 400 volt. Here it is written, that is which voltage? I have told you this is
Line voltage.
Line voltage. Very good. So now we are using a three phase variac. Three phase variac is used to vary three phase voltage. Single phase variac you have used to vary single phase voltage. Three phase variac we are using to vary three phase voltage. And here you see a voltmeter is connected between two lines. Between these two lines, R and Y, the voltmeter is connected. That means it is measuring which voltage? Tell me. Between any two lines, if it is measuring the voltage, that is which voltage? Just now I told you.
Line voltage.
Line voltage.
Line voltage.
Line voltage.
And this one is which current? Current which is flowing in the line, that is which current?
Line current.
Line current. Okay. Line current, this is measuring the line voltage. So line current, line voltage, if you will measure wattmeter, both wattmeter reading will give you root 3 VL IL cos theta. So if VL is known, IL is known, from the equation you can find out the power factor. Am I clear or not? Tell me. Got it or not? Tell me.
Yes, ma'am.
Yes. So here we are putting the loads in case of we are using unbalanced load. I think unbalanced load also madam will show you. Madam, unbalanced load ta dekho chunna?
हाँ मैडम लिखा होची.
Okay. Unbalanced load I have told you. So here you will find out the power factor. Measurement of the what is the power you are measuring. From the equation you will find out the power factor. VL, IL, you will equate it to root 3 VL, IL cos theta. From there you will find out the power factor. Okay. So this much you will do it in the lab. Here you see power factor formula I have told you. Clear to all of you? Any question? Tell me, or you'll see the video.
No, ma'am. No question.
Madam, I will stop कर देली sharing. आपन
हाँ मैडम हाँ स्टॉप करो. थैंक यू मैडम. Okay student. So this is three phase power measurement. What is aim? Shivam Kumar.
Yes, ma'am.
What is aim of your experiment? Tell me.
Ma'am, to find out power, ma'am.
Which power?
Line power, ma'am. Three phase power. Line to line
Three phase
voltage.
power. What is the formula for three phase power?
Ma'am, formula just now ma'am told that we will W1 plus W2 by finding from that wattmeter, ma'am.
Wattmeter. That is we are measuring. But what is the formula for three phase power? Anybody?
3 VI cos root 3 VLIL cos.
Root 3, yes,
Root
ma'am.
3
Root
VLIL
3
cos.
VL
Root 3 VL cos theta.
Very good. Root 3 BLIL cos phi or 3 B phase I phase cos phi.
Yes,
Okay.
ma'am.
In three phase, ma'am has already explained everything. Phase voltage, line voltage, phase current, line current. Because when we are considering single phase, only one voltage, one current is there. But when we are considering three phase, there are three voltage, three line voltage, three phase voltage, three line current, three phase current are there. Yes or no? Line voltage, what is line voltage? Exactly the line voltage is between two line or two phase. Yes or no?
Yes, ma'am.
Yes, ma'am.
Then phase voltage is any phase. Line current, phase current, everything ma'am has explained very nicely. But come to our experiment. Our experiment is to measure the three phase power for balance, unbalance both. Okay. But here you see, I'm just let me clear whether it is audible or not.
Engineering lab.
Is it audible?
Yeah,
Yes,
ma'am.
ma'am.
Audible.
Yes, ma'am, it is audible.
Okay, I'm directly going to the circuit, three-phase circuit. There I will explain, then play the video. The circuit is visible, student?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. The circuit
Yes,
is
ma'am.
visible.
Visible.
Just a minute. Here you see three-phase supply is there. Okay, now it is visible. Three-phase supply RYB. This is the standard voltage, actually 415 volt, 50 hours supply. Here we are using MCB instead of ICTP. Okay, what is ICTP? ICTP, all of you know, na? ICTP in single phase we are using ICTP, iron-clad double pole main switch, but here ICTP iron-clad triple pole. Okay, but we are not using this nowadays. We are using MCB. What is the full form for MCB?
Miniature circuit breaker.
Miniature circuit breaker.
So this is MCB. Okay, then come to R is one phase, Y is one phase, B is another phase. Three phases are there. Then we are giving the supply here. Three loads are there, A, B, C. Okay, we are using lamp load, A1, A2, one phase, B1, B2, one phase, C1, C2, one phase. Okay, tell me the load connected in which type of connection is there? This is which type of connection?
Star.
Anybody?
Star connection.
Star connection. Yes, very good. Because all the similar ends are connected at one point to form a common or neutral point. This point is the neutral point, which is not available in case of delta. Okay, so this is the load. This is star connected load. This is our supply. In between this, we are using the instrument. Okay, to measure the power. What are the instrument? Three ammeters are connected in series. Then one voltmeter. This voltmeter measures which voltage? Tell me. The voltmeter is connected across where?
Ma'am, line voltage.
Yes, obviously, because it is connected across R and Y. Two lines, or your AB, two phase. So it will measure the line voltage. Okay, then we are giving the supply through three-phase variac because we have to vary the voltage. Already ma'am is told three-phase variac, it is nothing but auto transformer. Three-phase auto transformer we are using to vary the voltage. Here two sides are there, input and output. This is input part, this is output part. Input we are giving the supply to input of three-phase variac. R directly connected to A1, Y to A2, B to A3. So E1, E2, E3 are the output terminal. So this we are giving the supply to the load through the meters. Okay, here we are using 3 ammeter to measure the current because we are using both for balance and unbalanced load. So for balance, you see what is the current in the ammeter. Obviously, what do you mean by balance load? Anybody?
It is equally distributed, ma'am.
What is equally distributed? The resistance of all the phases.
Yes, ma'am.
Resistance or impedance in all the phases are same. So that same current will flow across all the phase. Understand?
Yes,
Suppose here we are using 200 watt lamp, here also 200, here also 200. Obviously the current will be same for all the phases. This is your balance load. If here we are using 200, here 100, here 200, any one load we are using different.
It is unbalanced.
That is unbalanced. Okay, so obviously the current will be different. So that's why we are using 3 ammeter. Then voltmeter, it will measure the line voltage. Then come to wattmeter. Here how many wattmeters are there? In the circuit, how many wattmeters are there, student?
2, ma'am.
2 wattmeter. That means we are using 2 wattmeter. Then what are the possibility of wattmeter? This is 2 wattmeter method. We are saying 2 wattmeter method for power measurement. Also single wattmeter method is there. Also 3 wattmeter method is there. Okay. Tell me, single wattmeter method is used for balance or unbalanced load?
Ma'am, for balance.
Obviously, because if we are using the same load, then the power across any phase is equal to the power across other phases also. So if we are using one single wattmeter, we multiply it to 3, then we are getting the balance power for 3 phase. Okay. If we are using unbalanced load, then suppose you are 200, you are 100, you are 60 watt, then we have to use 3 different wattmeter, 3 wattmeter across all the phase. Yes or no?
Yes, ma'am.
But 2 wattmeter method, remember, it is used for balance and unbalance both. Okay, it is used, 2 wattmeter method is used for balance and unbalance both the load. Okay, here you see it covers R phase, also you see first phase also, in also B phase, also in the Y phase. So across all the phases it is connected. These 2 wattmeters are connected. That's why it is used to measure both for balance and unbalanced load. Okay, then in video everything sir is explained. You just see, any doubt in any point you ask me at that time. Otherwise it will be difficult to explain. Okay, so I am just playing it. See it carefully. Little bit it is lengthy because so many equipments are there. So wire connection should be too much clumsy. You just see it one by one. Sir is explained. Any doubt at any point you may ask at that time.
Welcome to Basic Electrical Engineering Lab. Today we will perform the experiment to measure the power of 3-phase balanced and unbalanced circuit in star load. So here our objective is to determine the total real power consumed by 3-phase load. And second one is to calculate the power factor of 3-phase load. So here, before going to details of the experiment, so look at the equipments. What are the equipments we are using, and the table where we are going to perform the experiment. So this is the table where we are going to perform the experiments, and these are the resistive load bulb, incandescent bulb we are using for this experiment to measure the 3-phase power and power factors. And what are the experimental equipments and measuring instruments we are using for this experiment? Here, this is ammeter to measure the current. This is wattmeter to measure the power. Its range is 0 to 400 watt. This is another ammeter to measure the current. These are the voltmeters we are connecting to measure the phase voltage and line voltage. And this is another ammeter to measure the current, and another wattmeter to measure the wattage. And this is the main, this is your 3-phase variac. We are varying the supply voltage by using this 3-phase variac. And here, this is the variable. And here these are the respective terminals, input terminals A1, A2, A3, and E1, E2, E3. This is the output terminals. So what are the equipments required? Look at this. What are the equipments required? Voltmeter, AC 0 to 300, 600, 2 ammeter, AC 0 to 1 ampere, 2 tungsten filament specification, this is 6, and 3-phase variac or auto transformer 0 to 415, 32 ampere, 1. And connecting wires as per required. Now look at the circuit diagrams. Here this is the R, Y and B, 3-phase 415 volts 50 Hz AC supply. So we are applying this AC supply to ICTP, iron clad triple pole. So instead of ICTP, we are using MCB, miniature circuit breaker for the 3-phase. Then after ICTP, this is our variac. We are using this variac to vary the supply voltage. Here, these are the 3-phase supply voltage. This is the input terminal of the variac, A1, A2 and A3, and corresponding output terminal is E1, E2 and E3. So after these output terminals, we are connecting these RYB 3 phases to the wattmeter through ammeter. Here we are using one ammeter in R phase 0 to 1 ampere. Similarly, we are using another ammeter in Y phase 0 to 1 ampere. Similarly, another ammeter we are using in B phase, same 0 to 1 ampere. So after that, we are connecting the ammeter output with wattmeter main terminal. Here wattmeter M stands for main, L for load, C for common and V for voltage or potential terminal. Between this M and L, CC is current coil. This coil, it has very low resistance and mainly the circuit currents or the load current, it will pass through these current coils. And this current coil is connected in series with supply and load. Similarly, this is the pressure coils connected with parallel. So here from ammeter output to M, L to A1 of the load. Similarly, another ammeter E2 to direct B1, and third one is ammeter output M and L to C1. And here the V terminal of these two are connected with this E2 terminal B1 and MC short. Okay, so now come to the circuit description in physical mode. This is our MCB or ICTP. ICTP, instead of ICTP, we are using this MCB. This is TPN. This is called TPN, triple pole and a neutral. So it has 1, 2, 3, 4 for 3-phase and a neutral. This is called TPN or MCB, miniature circuit breaker. And the output of this MCB, these are the 3 terminals R, Y and B. So from these input terminals, we are connecting, this is our R phase to A1 of variac. As per the circuit diagrams, this is A1. Similarly, for yellow phase, we are connecting to the A2 of the variac. Similarly, third one is the blue wire. From B, it is A3 of the variac. And corresponding output of A1 is this one, E1. This E1, it goes to the A1 of the load through measuring instrument. These are the measuring instrument we have connected. Similarly, from Y1 also, this is the output, this is E2, yellow phase. Through measuring instrument, we are connecting B1. Similarly, from E3, last one, this is the E3. Through measuring instrument, we are connecting C1. So now come to these measuring instruments, how our measuring instruments are connected. So first starting from red phase. This is the output from the E1 terminal. This terminal connected to M of wattmeter, that is the main terminal, M of wattmeter. MC sorted, and from the L terminal, this is the L terminal. From the L terminal to ammeter input terminal, then from ammeter output terminal to A1 of the load. Similarly, starting from output of E2, this is the E2 terminal, to ammeter one terminal, then from ammeter other terminal to B1. Similarly, the third one, E3, from E3 we are connecting to another wattmeter M terminal. MC is short. Then from L terminal to, this is the L terminal, L to another ammeter, and ammeter 1 ampere terminal to return C1, and 1 voltmeter we are connecting, you see, this is the B1 terminal, from B1 to voltmeter terminal, and the other terminal of the voltmeter we are connecting to C1, sorry, B2. So the voltmeter B1 with B2, here C2, B2, A2, these three are connected to form a star. This is the star connections. In the star connections, all the second terminal of the load are connected. So we are connecting this voltmeter across V1 and B2. So that's why this voltmeter, it will give the phase voltage. Another voltmeter we are connecting, you see, one terminal, this one, with A1, and the second terminal we are connecting in B1. So between A1 and B1, we are connecting another voltmeter to measure the line voltage. So this voltmeter reads the line voltage and this voltmeter reads the phase voltage. And this wattmeter terminal, the voltage terminal of this is the 600 voltage terminal of wattmeter 2, and this is the 600 voltmeter terminal of wattmeter 2. Both are shorted and it is directly connected to the B1. So as per the circuit diagram, our circuit connection is complete. Now we have to start the experiment. Now it is the supply voltage, it is coming nearly more than 400 voltage and 3 indicators going. Now I am increasing the voltage by using this variac. Let I am applying 100 line voltage.
That is 100. Line voltage is 100. Line voltage is 100. That is line voltage is 200. Yes. Give it.
Now we are applying line voltage to this setup. Here we are using a multi-range voltmeter. The lower scale is 300 and upper scale is 600. So for the 200 voltage, I am setting at 100. So now it is 200 line voltage and our phase voltage is, this one is the phase voltage.
It is around 112.
The phase voltage is 112 and red phase current is, here I am connecting in 1 ampere for this 0.367, 0.37
IB.
And the yellow phase current is, this is 0.3567, 0.38, 0.38, and the blue phase current, it is coming this is 0.373532. And the B phase current is 0.37. This is 0.37, and W1 wattmeter, this is 10, 14, 15. And W2 wattmeter, this is nearly 15.
20.
20.
20.
Okay, as the connection of this W1 is, okay, as the link connection you see, this is series connection B1, B2, and we are connecting this voltage terminal at 600 volt. So as per the multiplying factor table, its multiplying factor equal to 4 for W1. Similarly, you see for the W2 wattmeter, this is B1, B2 series connections, and here also 600 voltage connections. So as per the calculation point of view, the same multiplying factor here, 15 into 4 for W1 and 20 into 4 for W2.
Next reading.
So for the next reading, you have to increase the voltage
250.
to 250.
125.
So here we have to set the pointer
Bus.
at
Bus.
125.
कम करेंगे 130 थोड़ा सा बस ठीक है
Now it is
125 मतलब 150
125, that is 150, 250, and here
72, that means 144.
This is 250 voltage, 144, and corresponding I1,
IR.
red phase current 0.41, 0.41, and for yellow phase, this is 0.42, 0.42, and for blue phase,
0.41.
it is 0.41,
W1.
and for W1 equal to
20.
20,
4.
20 into 4, and for W2
30 into 4.
30 into 4. So this is for next third reading.
300.
For the third reading, I will increase the voltage up to 150.
That was 300. Out again. थोड़ा सा बस.
Now it is 150, that means 300 voltage line voltage, and corresponding phase voltage is
170. 172.
172 is the phase voltage. IR equal to zero 0.45. IY equal to 0.47, and B equal to 0.45, and W1 equal to
25.
25 into 4. Similarly, W2 equal to
40 into 4.
40 into 4. So this is the reading at 300.
Any doubt, student, up to this?
Oh, wait,
Hello?
we have to write that offline again.
No. I will give the reading. Another 2 readings will be repeated. Okay, same process. So I'm just omitting these 2 readings. After completing the unbalanced load, all the reading I will give you. Okay, no, don't worry. I'm just giving you the. I'm just showing you the unbalanced load. For unbalanced load. Okay.
Okay.
Because the same process will be repeated, so it will take some time. Just a minute.
To stop the experiment, now switch off. Now we are performing the same measurement of 3-phase power using unbalanced load conditions. Here you see we are using instead of a 200 wattage bulb, here we are using 100 watt bulb. In R phase, this is in Y phase and this is in B phase. So in Y and B phases we are using 200 watt bulb, but in R phase we are using 200 watt bulb. So now this condition is unbalanced conditions. So in this unbalanced conditions, now I am applying voltage using MCV. The same voltage it is coming. It is nearly 400 voltage. Now using variac, I will increase the voltage. This is the line voltage. I am increasing the voltage. Same 200 voltage I am applying. And you see the bulb conditions. These bulb 200 volt bulbs, these are less brighter than 100 watt bulb. And now this is the line voltage, 200 voltage, and here the phase voltage is 104. Now the line voltage is 200 and phase voltage is 104. IR current, red phase current is 0.24, and IY, yellow phase current is 0.37, and B phase current is 0.35, and W1 equal to 10 into 4, and W2 equal to 15 into 4. Similarly, now I am increased from 200 line voltage to
250.
250 line voltage.
कम करो थोड़ा सा बस ठीक है ठीक है
Here the phase voltage is
130
voltage. IR current 0.267. 0.27 and
41
IY equal to 0.41 and IB is nearly
0.39
0.39. Wattmeter reading 12 into 4 and W2 wattmeter 2
20
into 4.
फास्ट है ठीक है next
Next I am increasing the voltage
300
from 252.
So same process, it will be repeated for last 3 reading. Okay, so all of you understand what is the difference between balanced and unbalanced load and how the current, power, all the reading were taken. Any doubt? Hello? Any doubt of anybody?
No.
Okay. Yes. Okay, then I am giving the reading. Just take the reading. Just you see. This is for balanced load. Okay, measurement of power, 3-phase power for balanced load. Here you see, this is the, what is the relation between phase voltage and line voltage in star connection?
Ma'am, B phase equal to BL by root 3.
BL by root 3 or BL is equal to root 3 B phase. Very good. Okay. And the
मैम योर
relation
स्क्रीन
between,
यू आर शेयरिंग समथिंग मैम
मैम शेयर नहीं
Yes.
किया आपने अलग कुछ
मैम आपका शेयर नहीं हो रहा मैम बोर्ड
okay, okay.
यस मैम
Sorry. Now it is visible.
यस मैम
Okay, here you see, this is the reading for the measurement of 3-phase power, balanced load. Okay, this is your line voltage, this is the phase voltage. Yes,
मैम थोड़ा वेट कीजिए मैं वो टेबल कर रहा हूँ
हाँ मैं दे रही हूँ, पहले सुनो, उसको स्क्रीनशॉट ले जाओ, ये है मैं समझा रही हूँ, डोंट वरी. ओके, स्क्रीनशॉट ले जाओ. You see, this is the line voltage and phase voltage. The relation is line voltage is equal to root 3 times phase voltage, and phase current, line current, both are same for star connection. Here you see IR, IY, IB, all are line current or phase current. Anybody?
Ma'am, line current.
Very good. Because the ammeter, all the ammeters are connected across the line. If we are connecting also in the phase, then also same current will be coming. Okay, as it is star connected load. So you see IR, IY, IB approximately all are equal or not? Just 0.01 difference is there in IB phase.
यस मैम
Because it is balanced load. Okay, so take the screenshot.
दिस इज फॉर बैलेंस्ड
Yes, this is for balanced load.
यस मैम
Completed.
यस
See the unbalance. Here you see, this is for unbalanced load. Same, the relation phase voltage, line voltage, but see the reading. IR, IY, IB. Okay, tell me in which phase sir is connected the different load. RYB in the balance condition, all the lamp are of 200 watt each. Yes or no? But when sir is taken for unbalanced load, sir has changed the lamp across one phase. In which phase? Tell me.
IR मैम
Yes, R phase. Okay, that's why you see the reading. Across R phase, you see IY, IB approximately equal. Yes or no? Because
ma'am.
same
Yes,
load.
ma'am.
But IR, you see it is less current in comparison to these two, as it is 100 watt lamp each. So this is the difference between balanced and unbalanced load. Okay. Obviously, if we are changing the load, then the current will be, the resistance will be changing and the current also changes. Take the screenshot. Completed?
Yeah, ma'am.
Okay. Then we are going for the online experiment. Just I am giving the link.
Ma'am, as already given, ma'am.
Already given? Okay. So link is there. You see? My screen is visible?
Yes, ma'am. Visible.
Okay. So tell me what will be three-phase power measurement. See the circuit. Same circuit is there or not? According to what circuit, what video we are showing in offline. The same circuit is there. Yes or no?
Yes,
Yes, ma'am. Same circuit.
RYB phase, ICTP or MCB, then fuses, then you see 3 ammeters, 1 voltmeter, 2 wattmeter, and the load. Here, which load is used? R1, R2, R3. The load is, the type of load is
Balance.
balance and resistive load. Yes or no?
Yes, ma'am. Yes, ma'am.
There we are using lamp load. Here we are using resistor. Okay, and it is the symbol represent that it is fixed or variable. This resistance is variable or fixed?
Variable.
Okay.
Variable, ma'am.
It will be variable. And here it is written 25, 25, 25 ohm each. So obviously it is for balance load. Okay, the circuit connection, everything will be same. Now you see all the reading are at 0. We are not changing or we are not giving the supply. Okay, not switch on the supply. Then here the voltage is there. We can vary it. The option is there to vary the voltage. Also the option is there to vary the load. Okay, we are in two manner we are taking. In offline, as we are taking the load once, we are not changing repeatedly. For first reading, suppose I am giving 100 watt, then for second reading 200, it is too difficult. Yes or no? That's why there we are using, there we are changing the voltage. Okay, but here as it is simulation, the option is we may change the voltage, we may change the load. Okay, but you prefer to change the voltage by keeping fixed the resistance. Is it clear or load?
Yes.
Clear to all of you? And
Yes,
here you see 25 ohm each, but no option is there to change the resistance here or change the load here. If I want to change here, no option is there. Okay, how we can change? We can change here. Okay, suppose I want to change it to any value, you can change, suppose 30, 40, 50, any value, then click, then all the value are changing. Is it clear to all of you?
Yes, ma'am.
Because it is balance. Okay, so at the same resistance value, suppose I am giving the reading, I am taking the reading 25, I am keeping 20. After changing, you click once, then it will be changing for all the load. Okay, then voltage by default it is 100. At 100 volt, I want to take one reading. Suppose I want to take it at 100 volt. What you have to do? Just directly you switch on the supply. Frequency already given 50 hertz. Don't change the frequency. Then switch on the supply. It is on. Yes or no?
Yes, ma'am.
Now you see all the readings are coming in the meter and also in the load. It will be written 100, 2.30 something, 2.30. Then here it is wattmeter reading is there. Okay. Then fill the table. Then you see automatically the reading is coming. Clear? Or any
Yes,
doubt?
ma'am. No
Yes.
doubt.
Okay.
No doubt.
Very easy. Very easy.
Ma'am,
Yes. Yes.
ma'am, please explain again how to take the readings.
Again, I will explain. Here by default 100 volt was there. I will change it to 200 suppose. Okay. Then directly you switch on the supply. Here you click. The supply will be on. Then the readings, all the readings are coming. Nothing to do. Fill the table. You click fill the table. Then automatically the reading is coming. Is it clear?
Yes, ma'am.
Okay. Then you see, suppose I want to take 300. I want to take for 300. What will happen? You just see. Then switch on the supply. Here you see, click on fuse indicator repair. Why? It is not coming. Anybody? What's the problem when I am taking it for 100? 300?
स्विच ऑन नहीं है.
Switch on नहीं है.
अरे फ्यूज खराब हो गया ना एक्चुअली.
स्विच ऑन कर रही हूँ ना, फ्यूज काम नहीं कर रहा है. क्यों? फ्यूज क्यों खराब हुआ? हाँ?
Because resistance value is too low, ma'am.
Very good. The resistance value is too low.
Yes.
Okay, we have to
Yes,
increase the value of resistance. Otherwise, because as the resistance value is low, the current will exceed. That's why the fuse will blow. We have to change the resistance value. Okay, any value, suppose 50, I will change it. You change it to 50, then switch on. Now it is coming. Clear?
Yes, ma'am.
Also for 400, up to 400 you will take the reading. Also for 400, same
Ma'am,
process.
then no need to do the calculation. Just we have to.
No. I am explaining. It is not completing, na? Just wait. Fill the table. It is coming. So what you have to do, you already have know that it as at 25 ohm resistance, if we set from the beginning, we are not able to take the reading for all the value. Okay. So from starting, you may take it 50 or above 50. Any value, 50, 60, 70, 80, any value. Understand? Got it or not?
Ma'am, we have to take the same resistance reading for
Yes, same resistance, because at a time we are not changing the load and voltage. So you take the same resistance from the starting. You set it at 50 or above 50, any value. Okay. And vary the voltage. Up to 400 you have to take. So from 100 you take 100, 200, 300, 400 or 350, 400, like this you take. Is it clear? As it is simulation, it has the option to take very high voltage, but we are not taking because offline it is not possible. So up to 400 you take the reading.
Okay, ma'am.
Understand?
Okay, ma'am.
Up to this all of you clear?
Yes, ma'am.
Then in your objective, you have to calculate the power. You have to calculate the power factor. Yes or no? Measure the power factor also, or find out the power and power factor, three-phase power and power factor. Tell me, what is the power factor value here? Anybody? What is the possibility of power factor? How much it will be? Power factor depends upon what? RLC already considered.
Phase.
That is depend upon the load. Yes or no?
Yes, ma'am.
We are using three types of load basically, na? Electrical load, resistive, inductive, capacitive. So according to load, it will be vary. Okay, here which load is there? Resistive load.
Resistive load.
In case of resistive load, what is the power factor value?
Positive.
Yes. In case of resistive load, the angle between V and I is what? In resistive.
Cos theta.
Cos theta is how much? Cos phi or cos theta is how much? The angle between voltage and current is
0.
Number 1.
Yes, it is 1 because power factor is nothing but the cosine of angle between voltage and current. Yes or no?
Yes,
But
ma'am.
in case of resistance, the voltage current both are in phase. So the angle is 0 and cos phi value is 1. So power factor must be 1. But here you see, is it 1? No, no.
No, ma'am.
Why it is not 1? Because you see, along with this also wattmeter coils are there. Maybe as it is simulation, so maybe the effect of this inductive load is there. That's why it is not coming 1. But so what you have to do? You have to do the calculation. No need to do the calculation for all the reading, for any one reading. Okay. What
Okay,
calculation you have to do? Listen carefully. Measured power, it is W1 plus W2. By default, it is there. Measured power, W1 plus W2. What is calculated power? Calculated power means we have to calculate it. Okay. How we calculate? By formula. Yes or no? √3 VLIL cos phi. This voltage is your line voltage. Also the current is the line current. Yes or no?
Yes, ma'am.
Voltage current both are line voltage, line current. So √3 VLIL cos phi. But we are not taking this cos phi. Why? Because it is not correct. Okay. How you calculate cos phi? W1 is there, W2 is there. What is the formula? In the manual it is written. Also I think ma'am has explained. What is the formula for phi?
Tan inverse √3 W1 minus
Tan inverse W1 minus
Very
W2
good.
upon W1 plus W2.
Very good. Okay. So by that formula, you calculate cos phi. And you see that it is coming nearly equal to 1. That is correct. Okay. After getting 0.9998 like this, it is coming. Not this is the correct value. So from this W1 and W2, any one reading, you do the calculation for cos phi value and check the calculated power, whether it is coming the same or not. Calculated power, you use the formula √3 VLIL cos phi. Which cos phi? The calculated cos phi. Is it clear to all of you or any doubt?
No doubt. Yes.
Okay. No need to find out for all the reading, for any one reading. Then we are proceeding for the unbalanced load. Then you see same thing, same circuit is there, only the load is unbalanced. Here you see every where we can change the load. Understand? There is the possibility to change the load as it is unbalanced. So already it is unbalanced 120, 160, 180. In the same process, you just do for one reading. By default it is 100. Switch on the supply, fill the table, then the reading is coming. Is it clear?
Yes, ma'am.
Can you tell again for it?
Again, I am taking another reading. And here you see VRY, VYB. What are these two voltages? Line voltage. And here, when you are changing the voltage, you have to change both the voltage. Because in offline, we have no option for different voltage, line voltage. Same line voltage across VRY, VYB, VBY, VRB, everywhere. Okay, that's why suppose I will change the voltage to 200. Then also VYB, I have to change the voltage. Okay, same. Both the voltage we have to change and keeping fix the resistance value. The value you keep it fixed. Then same process, switch on the supply, fill the table. Clear? The reading is coming. Any doubt?
No, ma'am.
No doubt, ma'am.
Then again, suppose I want to change it to 400. Then both the cases you have to change 400 and 400, both the line voltage. Switch on the supply, fill the table. Just you take the reading here, no need to do the calculation, any calculation. Only for balance load, you have to do the calculation for cos phi and the calculated power. So, all of you clear about the experiment or any doubt? Still, anybody having any doubt, you may ask now. Okay, all of you getting how you have to do. If anybody completed, you may share and also do the calculation. Any one calculation, you just say so.
Ma'am, in unbalance खाली voltage change करना है ना, बाकी सब तो default value लेना है.
हाँ, बाकी.
Only voltage. Okay. Only voltage you have to change. Resistance value is already given, na? Unbalanced different value.
Yes, ma'am.
For both the cases, you have to change the voltage.
Okay.
In balance also, you have to set the resistance once and change the voltage. As it is by default, it is coming 25. We are not taking 25 because for higher voltage value, the readings are not coming. That's why I am setting it at 50 or above 50. Any value above 50 you can take. Clear? Understand?
Yes, ma'am.
I'm stop sharing now. Then 10 minutes is there. You just anybody share who have completed and just do the tell what is the calculated value of cos phi.
Ma'am, completed the online part but haven't completed the calculated part.
Okay, calculate करो. कितना टाइम लेगा? बहुत कम टाइम में हो जाएगा ना? Just do the calculation.
Ma'am. Ma'am, that only we have to calculate power factor, no?
Yes, only for any one reading, not for all. Any one reading.
Ma'am, I have calculated for one, like it's coming 0.86.
Yes, 86.
Yeah, ma'am.
W1, W2, you have taken?
Yes, ma'am. W1 plus W. Wrong, ma'am.
No. You calculate again.
Okay, ma'am.
Tan inverse root 3 W1 minus W2 divided by W1 plus W2. Then cos phi. It is not coming 0.86. See how much it is coming. Okay. Okay, who is completed? You can share the calculation letter. Any 1, 2 student, please share who have completed.
1 minute. Ma'am, I have taken the screenshot.
Okay, no
Can you see it?
Yeah.
Ma'am, this is for the balance.
Okay.
Ma'am, and this is for the unbalance.
Okay. Do the calculation, okay?
Yes,
and tell
I'm
me.
doing it.
How much
I'm doing it.
Yes, yes. Any other?
Ma'am, can I present?
Yes, yes, Anchal. Share करो.
मैम मेरा भी हो गया, मतलब कैलकुलेशन नहीं हुआ.
हाँ, वेट करो, कैलकुलेशन करो. अंचल के बाद शेयर करना.
Ma'am, this is for unbalanced.